evolution, if you'll circle the word evolution, evolution means a change in the population over generations. Now, what you were just talking about with the cricket was not evolution. If some of the crickets lived and died, that would be called natural selection. But if over many generations we saw that the population had drastically changed, don't watch the video, watch up here. If over time the population drastically changed, then we would call it evolution. So evolution is a theory, but it's based on evidence. It's based on looking at which organisms survive. So this theory was started by a man named Charles Darwin because he went sailing from England over to the Galapagos Islands, which are on the northwestern coast of South America. And he went to these islands and he saw that on each island there were slightly different birds called finches. One of the islands had all birds with really long, thin beaks. And one of the islands had birds with all really short, fat beaks. And Darwin wanted to understand, how can they be that similar to each other and yet have that different size beaks? And his theory is that the environment, put a big star around environment. The environment, now put a star or a circle around the word select. That nature or the environment selected for those birds. And he found things in the environment to show that. The island that had all the birds with the long skinny beak, that island had a lot of cactuses. And the birds with the long skinny beaks were able to get their beaks in there and pull out the seeds without getting stabbed. But the other islands didn't have a lot of cactuses. And so his theory is that the island and the features or the environment had selected for those birds to be successful. So natural selection is when organisms are selected to survive because they are, we're going to change this from best adapted to best fit. Best fit, meaning fitness. Now we said that being fit means you get to what, everybody? You get to, starts with an R. Reproduce. So if you get to reproduce in that environment, if you live long enough and eat enough and find a mate and you get to reproduce, you're best fit. But if we take you out of your environment, you might not be best fit there anymore. So we're going to see that natural selection...
So they got to adapt.
That's a good question. Can you adapt? If I push you off a bridge, will you adapt and grow wings?
No.
Nope.
Oh.
If we put those light-colored crickets in a dark environment, will they adapt and turn dark colored?
Probably.
No. After time.
They'll learn how to survive.
What? Will they always? If I push you off a bridge, will you learn how to survive? No. So you bring up a really good point in that this idea of learning. Some animals can learn, but sometimes you can't. Think about the polar bears and the shrinking ice. Yes, now the polar bears have to swim further. Even if I teach a polar bear that you have to swim further, can polar bears swim infinitely long periods? No, they'll eventually drown. Because even if they learn, I need to swim further, sometimes they just can't do it. If I push you off a bridge and you learn, I need to fly, it doesn't matter how much you learn, you need to do it. You can't ever adapt. So that's why we're changing that word adapted until a little later when we know what adapt means. And so Darwin's idea is that if there was a common ancestor, if there was one set of birds with all sorts of differences, Then where there were insects, this bird would be successful. Where there were leaves, this bird would be successful. And so what's most important is number one, that there is variation. In order for natural selection to happen, there has to be variation. Members of the population are genetically different and therefore have different phenotypes. If all of the organisms are exactly the same, then they all survive equally. But if some of them are different, then some might survive better than others. So the first thing that has to be there is variation, and I need you to put a star by genetic variation. Because I could go to the gym every day and work out and have really big muscles. But if I live long enough to have a baby, will that baby come out with really big muscles? No. So it has to be genetic variation. So put a big star next to genetic. The second thing that has to happen is overproduction. More members exist than what we call the carrying capacity can support. This means that not everybody gets to live. The third thing is competition. Whichever one best competes gets to reproduce. And so number 4 is about reproduction. Now we need to add in number 3, where we see competition, we need to add in what's called a natural selection force. A natural selection force favors the best suited phenotype. So let's go back to the example of the crickets, where Olivia said it doesn't matter if you're a dark colored cricket or a light colored cricket, because there was no bird or predator. So we can have variation, and we can have 100 crickets in there, but until there's what we call a selection force, it doesn't matter. They'll all survive. And so that selection force is really what favors, or next to favors, write the word choose. Chooses. The natural selection force is doing the choosing. This is something like a predator or a mate. Something in the environment, for example, food, Darwin's finches, is there enough food for everybody to get to live? And so we have to have variation, we have to have too many, and then we have to be picking which ones survive. Now humans do this really interesting, especially when we breed dogs. We pick which dogs we're going to breed, and then they have little puppies. And so this is how you got all the different breeds of dogs. Great Danes and Chihuahuas are because we bred all the big dogs together and got things like Great Danes. And then we kept saying, oh, look how cute the little dog is. I'm going to breed the little dog with another little dog, and I'm going to get more little dogs. And that's what we call artificial selection, where humans have chosen artificially who gets to survive. But in nature, variation, overproduction, meaning too many are there, and only some survive. But the key that we said is all about reproducing. Because if you don't reproduce, you don't get to pass on your genes. Those of you who have questions, if you'll do me a favor and hold them to the end, then when I turn the video off, we'll answer questions. I need you to keep in mind, natural selection does not give you what you need. If I push you off a bridge, you don't evolve and grow wings. If I have a bacteria and I put an antibiotic on it, it does not evolve to be resistant. It either is resistant or it dies. Because you can't change your genes. You have what you're born with, and you're either fit or not fit. So, mutations, remember, are what create variation. So, again, my software disappeared. I can't put a star by it. But put a star by right here. Mutations create variation. All of our mutations are what make us different from each other. So the light-colored cricket and the dark-colored cricket, they're different because of mutations. The unfavorable mutations are selected against, reproduction happens, and favorable mutations get to survive and reproduce. So you can see here we had an organism. We had 3 variations. This one didn't get to survive and reproduce. These 2 did. This one didn't get to survive. These did. And all of a sudden, the population has changed. It went from being a medium color to being a darker color. And that is natural selection and evolution. When natural selection and evolution happen, then we end up with what are called adaptations. Adaptations are inherited traits that help an organism survive and mate. So we have to quit thinking that we can adapt. Yes, some animals can learn. But learning is actually based on whether or not your brain can learn. And that's genetic. So being able to learn is actually an example of an adaptation. So I need you to be really careful, and I need you to really star that it's something that you inherit. I need you to star or circle that it's something that you inherit that helps you better survive. They can be structural. For example, the king snake and the cobra snake. The king snake and the coral. The king snake is poisonous, and it has these brightly colored stripes because it wants to tell the birds ahead, I'm poisonous, don't even come down here to eat me because I'll bite you and you'll die. Right? And that's an advantage. It's an adaptation, it's an advantage because the snake doesn't even want to get into it with the bird. It's trying to just warn the bird off. Hello, don't come down here. Now, some snakes that kind of look like the king snake, they get to survive. And that's what we call mimicry, because it mimics or looks similar. Let's add in the word looks similar. So we see these really interesting patterns of natural selection where it's all because they better survive. So structural ones, please go ahead and circle. It's a physical form. It is something physically about your body that lets you better survive. So if you're the rattlesnake and you have the rattle and you can warn people off, don't come over here. If you're a big giant elk and you have these big horns that let you fight off other males so that you can attract the females. These are structural or body characteristics that help you better survive and mate. We also see behavioral and physiological. So the fact that a dog or a lion or a wolf growls, that's an adaptation. They're trying to warn other members away. Don't come over here. And then physiological is something inside. So having a heart. Not all organisms have a heart that can pump blood. So humans have an advantage because we have a heart that can pump blood. If you're a jellyfish, you don't have a heart. They have what's called a nerve neck. And so they don't have a heart. So that's why jellyfish aren't nearly as big as humans, because they can't move blood through a big body. So they can only grow so big. So what we start to see is this idea that the mutations that you have let you be more successful. And so we have to remember that these mutations, you don't get them because you want them. They're from random mutations.